Good morning, good afternoon, and good evening from Helsinki, and welcome to the Pulse of Networks webinar series, episode 16. My name is Claus, and I'm the CEO of Creanord. Today's topic is user experience monitoring in modern data networks. But before we start, I want to advertise that all of our previous episodes are also available on our website. So if you are interested to look at some earlier topics, check under the option News and Insights on our website. There you'll find on-demand webinar, and under that option you will find all the previous episodes to be watched on demand. All right, very well. Let's get started. So why do we need user experience monitoring, and what are we actually talking about? To start with, let's look at this McKinsey study from 2022. In this study, they looked specifically at why the end customer choose a specific provider, why they left a service provider, and what drives the customer net promoter scores. In essence, this is the core of the service provider business, of course, to get new customers, to hold on to your existing customers, and to make sure that your services are promoted by your customers to new potential customers. And when we look at the results from this study, we see that roughly 40%, by far the largest category in all three cases, was related to the network and the network experience that the users are getting. The most important thing that you need to think about is to ensure that your customers has a good network experience. As you can see from this chart, the price is not the driving factor. It is quite important as well, but the network is the most important part to focus on. The results of this study are also supported by some recent findings from Ericsson research. They also found that now with the rollout of 5G and with the higher speeds, the users are already pretty happy with the download speeds that they have on their mobile phones, and what they are looking for really, again, is the network experience that the service provider is providing. Do you get a good voice quality? Are your videos starting up fast and play consistently throughout, and so on? Another interesting fact from the Ericsson Mobility Report is that the top 10% of data consumers use 70% of the traffic on their network. And if we again look at the light consumers with data consumption rates below 5 gigabits per month, which actually accounts for 2/3 of the entire customer base, a significant portion of that traffic is communication services with strict quality requirements like voice, video conferencing, and so on. And this study is on the global customer base. And part of these light consumers are, of course, business customers that like to use video conferencing, voice services, and other types of low data volume services. But on the other hand, when you are thinking from money perspective, these are the high ARPU users. So you could roughly say that the 10% of your low ARPU users are actually degrading or in the risk of degrading the user experience of the 2/3 of your high ARPU customer base, which is where you actually want to focus on. So that means that it is very, very important that you look at your network quality and particularly also the user experience, so you get a whole picture of how they are experiencing your network if you want to hold on to that 2/3 of your customer base and the high ARPU customers. It's not only that these heavy data users we talked about on the previous slide is using a lot of data from the network and in that sense congesting the network. It's also the nature of the data that they are consuming that destroys the performance of the network. Most of the data nowadays on the mobile networks is streaming video, which is very bursty in nature. And on the graph here, we describe a typical bandwidth profile when watching a streaming video service. And what is important from this chart is, first of all, we see that it's a pulsating sequence of microbursts, and how big bandwidth they consume and how long these bursts are depends on your downlink speed. So in the upper graph, if we have a 30 megabits downlink speed, the microburst will be something like 400, 500 milliseconds in length, whereas in the picture below, the microbursts are going to be much spikier. It's going to be consume a lot more bandwidth because I have a 200 megabits. It's going to try to achieve that 200 megabit full speed download and making the microburst much more aggressive and shorter. So we're talking about 100 to 200 millisecond microbursts in this case. And of course, as the downlink speed grows, the length of the microburst shorten and the spikes just go higher. The nature of TCP, which is used for the streaming video content, is to try to consume all bandwidth that's available, and that's what's causing additional problems. Now, what's the relevance, you may think? So the relevance is actually not from this looking at the single user, but the problem starts when we look at the transport links and what the bandwidth profiles looks for these transport links when we are aggregating many users watching streaming video. So on this next slide, we are looking at the traffic profile example where we have aggregated together 100 video users streaming video and how it looks on a 1 gig transport link in the network. Now, the average utilization is going to be independent of what sort of downlink speeds the users have. It's going to be around 400 megabits for this HD quality video from the users. However, the burstiness of the traffic is going to depend on the downlink speed. So the middle graph will show what sort of bandwidth bursts we will have when all of those users would have a 30 megabit downlink. Then we are around something like will momentarily consume 650 megabits per second from this transport link. So it's already quite aggressive in that sense compared to with the average of 400 megabits. However, when we look at the assumption that we have all of the 100 users have a 200 megabits per second downlink, then the traffic bursts get very aggressive. In fact, momentarily reaching 1.2 gigabits per second, which actually then, of course, will exceed the transport link capacity. So the link will only transfer 1 gigabits per second, roughly, which means some of the packets will be queued up in the device waiting for more bandwidth to be available, causing delays to the packets. If the burst is larger, the buffer is going to fill up, and you're going to also have packets being lost in these situations, meaning that some of the services on the network are suffering heavily from these bursts. As we can see, the higher bandwidth, the downlink speeds you get, the more aggressive your traffic profiles on your transport network will look like. And now we are thinking about 5G, rolling that out. You are getting 1 gig up to perhaps even 10 gig in some cases, downlink speeds to your mobile phones and your computers and so forth. So that means that the aggregate traffic is going to be very, very aggressive. Now, what does this do in terms of performance monitoring? Well, this new scenario for the modern data networks, it actually means that we have been quite used for many, many years to use SNMP to monitor the quality and performance of data networks. However, in this new situation, with these extreme download speeds now being offered to the users, this is no longer sufficient. It provides some valuable information, but it's not going to provide you with insights into how bursty your traffic is, and that means to actually what sort of user experience your end customers are receiving. With SNMP, you are polling data perhaps every 5 minutes, perhaps every minute, or even every 30 seconds, but that's not sufficient for you to get insight into the microbursts. Your reports are going to show that 400 megabit average utilization, but you are not going to see whether those microbursts are already, in fact, exceeding the transport link capacity. Now, another option for this would be to use passive monitoring. Passive monitoring solutions typically have good good capabilities to catch the microbursts and report on them. However, the issue with passive monitoring is it's looking at the local links where the hardware has been installed, and since passive monitoring solutions are typically quite costly, you deploy them at central sites. And so you only have visibility on the links kind of close to the central core sites. You don't see further out in the network where you actually have those links with less capacity and where you are likely to first see the issues with the microbursts. So the right option in this scenario to catch the microburst is to use active monitoring. So with the active monitoring solution, you can still deploy the active monitoring solution centrally on a centrally located site, sending out TMAP packets towards the base stations and intermediate router devices. But here you can have the sufficient granularity, sending out perhaps 10 packets per second, seconds, or 100 packets per second to really catch the microbursts and measure the delays that these microbursts are causing to your services. And that's the benefit with active monitoring, just generally in terms of monitoring the performance of the network. But in fact, active monitoring is also very well suited for measuring the user experience. For instance, if we are talking about measuring the user experience of watching video, it's actually the only way that you can measure that, because you have to simulate the user watching a video stream by downloading the video segments. This is not something that you can estimate, because the video player has a lot of functionality. It buffers video segments, it plays them out. You more or less have to write the code of a video player to be able to simulate this. So you have to have an active monitoring solution that simulates a user that actually watching a video clip, and then you measure the important KPIs related to that particular use case. Okay, so how do we measure the user experience? In this slide, I have summarized what I think are the most important user experience related measurements. And as you can see on this slide, I still kept TVAMP here as a very key part to also look at the user experience. For some data types, use cases, TVAMP is still a very good measurement protocols, but it's not enough to have a full view of your end customers' network experience. You need a lot of other measurements as well. I let here YouTube represent video services in general, and I just want to note that, of course, there are other also important video services that you want to measure: Netflix, some social medias, other streaming services as well. But in addition to that, you also, for instance, if we are talking about a web service, DNS, domain name service, can actually have a big impact on your user experience. You are jumping from website to another website, and whenever you are going for a new website, you're going to need the domain name service to find out where to get that web page. And if it takes a long time for this service to resolve the IP addresses, then that's going to look like the network is performing badly. And maybe important to note also that why it is so important to measure the user experience, that even if some of these services are not in your control, you are not providing the content distribution networks for YouTube, Netflix, etc. For instance, and you may be relying on somebody else to provide the DNS service, for instance. But it's very important that you still have the visibility to how these services work and how they affect the user experience. Because from the user perspective, it will still look like it's your network that is slow, although it might be some other component that is actually causing this issue. And if you know that your CDN is not performing optimally, you can work with your CDN partner provider to cache content closer to your end customers, or optimize bandwidths, etc., so that you bring the user experience up to the expected levels. So these are the different types of measurements that I think are important to measure. Then it depends a little bit on where your focus is. I think, of course, operators and the promise of 5G has been that you get a lot more revenues from business users. So it's of course very important to monitor the user experience of business users. But I think there is also a growing interest from operators to differentiate for the consumers by also offering excellent services, as we saw in the slides initially. That's the way how you get your customers and hold on to them. So there's also very important consumer-related user experience use cases. So let's look at these both and start with business users. So if we look at business users and kind of look at the top 3 services, I think voice services, video conferencing, and web services are what business users are commonly using and expect very good performance from. And these services have very different requirements, and there are different things that impact the experience of these services. So in terms of voice services, it's actually jitter would be the major factor affecting how the voice call is received. And if we look at what are typical requirements, if we look at end-to-end between the two persons talking, the jitter should be typically recommended is to be less than 30 milliseconds, which then if you are just monitoring your backhaul transport part, it has to be much less, of course. But this is for the end-to-end view, 30 milliseconds. So maybe in your backhaul, it's maybe 10 milliseconds or so. One-way delay is not that strict, so 150 milliseconds or 300 millisecond round trip delays. And packet loss, there's some different recommendations. 1% is maybe kind of the upper bound. Could be stricter requirements, of course, as well, but voice service can take a little bit of packet loss as well. And actually, for the voice services, TVAMP is a perfect measurement. It provides all of these critical KPIs, and you can use them to compare and actually see how the user is experiencing the service. And what you can further aggregate this measurement with also a voice mean opinion score KPI. And I'll talk a little bit more about the benefits here, but basically the idea is to take the KPIs produced by the TVAMP measurement and then combine all of those into a single score, which provides the overall user experience KPI. When we look at web services, 2 components that has the biggest impacts on the user experience. The DNS that I already talked about, and then the throughput. So when you're going for a web page, how long does it take to download that web page? And typical requirements for the DNS is 120 milliseconds, should be less than that. Throughput depends a bit. You can see different recommendation, and depends, of course, on the size of the web pages, but 3 to 5 megabits per second is typically providing quite sufficient user experience. So there's not very high requirements on the download speed or throughput speeds. And here again, this is something where those basic performance measurements are not really going to cut it. You need to simulate the user downloading a web page, measure that, measure the DNS service, how quickly is it responding. It's typically not really the network causing the delays, it's processing delay on the server side that's causing the majority of the delay. So you want to really use those services, perhaps monitor the top 10, top 50 websites that your end users are accessing, and check that the performance towards all of these web services as well as the DNS services is according to the requirements. When it comes to video conferencing, it's voice is an important part, but then we add the video there, real-time video in this case, so you cannot really buffer the video for too long. That causes more strict requirements actually than you have on a pure voice service. Recommendations from Microsoft is if you are looking at the portion between the company edge towards the first point of presence of the Microsoft internal network. One-way delays should be less than 30 milliseconds, jitter less than 15 milliseconds, and packet loss less than 0.1%. So it's a fairly strict requirements here. But if we look at the KPIs, the same applies as for the voice services. So TVAMP is a perfect protocol to use to measure this video conferencing user experience, and then combined with the voice mean opinion score KPI provides you some kind of simplified view of the quality. When we look at consumers, it's a little bit different. So here I took as what I think the top 3 things to focus on is first of all gaming, which on just generally also is very interesting. I'm going to talk a little bit more about that on another slide. The web is as important as for the business users. And then we have, of course, video here meaning streaming video, social media videos, and so forth. When we look at these 3 types of applications or services, when we look at gaming, so delay is really the main KPI to monitor there. And the interesting thing with gaming is really, I'm going to show some charts, but really the less delay, the better generally. And how much it's going to impact depends a little bit on the games and so forth, but the less delay, the better. So setting a strict recommendation on what's a good delay is difficult. I put here 50 milliseconds. Actually, it's depend. If you look at the certain type of games, you will see a big decline in the scores that you are getting once the delay grows beyond the 50 milliseconds. But regardless of any games, the less delay you have, the better. Again, TVAMP, a very good measurement to kind of provide this user experience. And why this is so interesting is I think there are some additional business opportunities with gaming. If you think about it, this is one potential. If you have young ones at home, you know how passionate they may be about gaming. If you can get any way your score higher, you will try to get those scores better and better. So, and as said, the less delays, the better scores. So I think this is a segment where you could really, by providing a differentiated service for the gaming services, you could actually monetize that from these players. So that's why it's a very interesting use case to look at and measure. Web services, well, same requirements, same monitoring as for the business consumers. In video, generally, if we are looking at the streaming video and so forth, it's typically not really the network itself that will cause degradations of the user experience, except if you have a very congested network. But since the videos are being buffered at the end user side, looking at streaming video, you will buffer tens of seconds of video, perhaps, depending on the player and how the video provider has chunked the videos. But you are still buffering many seconds of video, so you can take quite big delays from the network. So the CDN is actually the component that might be the biggest source of a degraded user experience. The content may be far away from the user, meaning that it takes longer time just because it's further away. The TCP is not working optimally. And so forth. There might be, maybe there's not enough capacity at the CDN provider and so forth. So that's really a typical source of degradations here. And there are very good KPIs to monitor with good research to suggest what the limits should be for these KPIs. In video, it's actually, you can summarize it very simply into 3 major KPIs that you want to look at. The first is the initial buffering time. So I start to watch a new video from Netflix or YouTube or whatever. I'm prepared to wait 2 seconds for that to start playing. This is what multiple research suggests, that 2 seconds is really the threshold if it takes longer, you will see a certain percentage of the users switching to other providers, to other contents. Depends a little bit on the research, then how drastically that or big that percentage is. I've seen even studies suggesting that if you wait 5 seconds, you might lose 50% of your users, which is kind of the kind of extreme values. And in some other studies show you lose less, but they all state that this 2 seconds seems to be a quite universal threshold. So you want to keep your initial buffering time below the 2 seconds. Then you know all of your users are quite content with the user experience. Another very annoying fact of video is when you are watching some content and the video suddenly stops and it starts to rebuffer the video and then continues after some time. That's very annoying, and there's also multiple research suggesting that at least if you have 2 or more of these events, you will already start to switch, or a certain percentage will start to switch streaming providers. So ideally, you really don't want to have any of these rebuffering events happening. And the same thing is with video resolution. Adaptive streaming is made such that if you have less bandwidth available, it will switch to lower quality video so that the chunks that it's downloading are smaller. That's also very, very annoying. You get a grained video picture, and that's not nice to watch. We are getting used to getting higher and higher resolution videos, and we do want to see the resolution in the original resolution. So here again, as said before, only way to really measure this is by simulating a user watching the video, for instance, the YouTube. And then what you can also do to aggregate here is there's very elaborate formulas made by the ITUT to take these 3 KPIs that I talked about, combine with everything else that you are measuring during that simulation, crunch it together in a quite complex formula, and then as an output you get a number between 1 and 5, the mean opinion score for the video, which is quite the same as for the voice service. So it's a very nice way to, just by looking at 1 KPI, to know whether your network is doing well or not. To summarize 5 different applications we talked about in this table, as we can see, actually for 3 of the traffic types, for the voice, video conferencing, gaming, if you have a normal active monitoring solution deployed, it can be quite successfully used also for getting user experience view of the network, how the users are actually experiencing the services. Whereas with the web and the video services, there you need to complement that with other types of measurements. And then again, both for video and voice, we have this mean opinion score, which I think is a very nice way to summarize the user experience into a simple to understand formula. Okay, just a few words on measuring the user experience. For instance, here as an example on YouTube videos, 3 important locations in your network where you want to put in measurement devices. So the first is, of course, to select some critical locations where you deploy a stationary probe simulating a user behind the base station, just with a connecting to the base station and really providing you the end-to-end view from the end user location towards YouTube. So that's an important part. You do want to have it stationary because if it's a user moving around, of course the radio network is gonna affect a lot your user experience. How far are you from the base station? Are you indoors or outdoors? Are you moving fast, etc.? And these are factors which really are unique for every user. But you want to have a general view on the user experience. So you want to kind of factor out that part. So you want to have the probe stationary and measuring continuously, so you can see that if somebody is reporting a bad experience in certain locations, you can check then from the baseline, this stationary probes kind of provide a baseline for how well the service is working. And if it looks good, then perhaps for that individual user reporting an issue, maybe it was something else happening, some issue with the radio network coverage, etc., that caused him to have a bad experience at that time. The second important location where you wanna put in a measurement device is just that as you are terminating the GTP tunnels at packet gateway UPF location, kind of where the mobile network ends and the internet starts. And why you want to have it here is because you are still going to transport that data over your own core network, which can also be a source of degradation of the experience, and that is still in your control. So you want to measure over the core towards the YouTube, so you can kind of have a segmented view and see, for instance, if you have a issue at the stationary probe behind the base station, the first thing to check is, of course, if everything looked good from your probe that you had at the packet gateway, and if everything looks good there, then probably the issue is going to be either with the mobile backhaul network or with the radio network. So you already kind of troubleshooted where in the network your issues are. And the third position where you also want to put one probe is then close to your peering points, internet gateways, where your public internet starts, so that you can measure from your network towards the provider of that video streaming service. And third component to see if any degradations in the video service was actually due to the service provider or to the internet performance. That's the way to kind of set up the architecture of this monitoring. Now, a few words still on gaming here. So on this slide, I'm looking at a few different games. In the upper left corner, I have the game Unreal Tournament, a first-person shooter game, and there was a study looking at the latency and the impact on the scores for the gamers. In this case, this report is for the hit fraction, how much you hit other persons, etc. And this is one of those games where you see, when you look at the graph at 50 milliseconds, the scores are going to go down quite substantially down to 100 milliseconds. And then as we increase the delays further, the scores or hit fraction is further decreasing, perhaps more linearly in after that. For a racing game, in the upper right corner, we can see that the increase in lap times in this case is quite linear. So the more delays, the more you have seconds are added to your lap time. So in this case, it's linear. And then the third, added it here because if you have young ones at home, again, if they have enough age, they probably play Counter-Strike, at least if they are boys. And you can see here that you also, for the Counter-Strike, you will have a linear decrease in scores in your hit accuracy and in the scores as the network latency grows. So as said, I think this is a great, very interesting opportunity if you are looking as we go further. And we are introducing, for instance, slicing in the network, which will provide you the means to also control the latencies on your radio network. If you have appropriate QoS measures and services installed in your transport network, you could provide a guaranteed service for your gamers to guarantee a low latency. And I'm pretty sure there's a big opportunity to cash in on that lowered latency from these persons. I think this proves pretty directly that all the milliseconds you can get off in terms of latency will benefit you a lot in terms of your scores and success in these games. I already talked a little bit about the mean opinion scores, and just wanted to emphasize this a little bit more, when particularly as we now are looking at user experience monitoring. It's a great tool for anybody, I think, but particularly also if you are thinking about getting the bird's view, executive view of how the network is performing, how the users are experiencing the network, because this is a very well-known concept. The mean opinion score has been there for many years, originally originating from actual users giving scores between 1 and 5. But ever since, there has been a lot of research, and now ITUT has formalized that so that we can also estimate how these users would rate their experience based on the measurements that we are running on the network. Those formulas are the results of quite extensive research and are actually quite complex, but the output is very simple. It's a number between 1 and 5, 5 being the best, and typically you are never really even able to reach the 5, because you are using different types of codecs, etc., that already by the nature of these codecs are lowering the quality of the voice and the video services. But in general, any scores above 4 is a very good score. And so if you generally measure the user experience and you are getting your measurements are showing that the MOS score is generally above 4, then you know you are really good. Once it starts going below 4, then some of the users will be dissatisfied, and the more it's below the 4, of course, the more users are dissatisfied. And then 3, you could say, is a kind of a cutoff point, that if you are below 3, then you really have a crisis situation for sure. Then most of the users are dissatisfied, very dissatisfied with the service, and you should immediately take action to bring that up. But it's a very nice way to summarize it, and available both for voice and for video. Definitely recommend to utilize this one when you are considering how to approach the user experience monitoring. Finally, I touched it a bit on in terms of video, but I want to just generally also talk about the segmented view when we are talking about active monitoring and in the network. Many times, even with our customers, it's very typical that you start by looking at the end-to-end measurements in terms of measuring from the core location towards the base station with TVAMP measurements. But if you want to, what you want to consider from day one is that once those measurements show that you have an issue, then you do want to know also where in the network you have that issue. So it's very important that you are also monitoring towards the intermediate devices in the network with TVAMP in this case, as we look at the network performance. But as we showed in YouTube, you also want to have for in terms of the user experience, look at these segments so that you know where in the network you actually have your congestions and where you need to focus your investments. So I think that's a general issue, as we talked about in the beginning of the webinar. As we have rolled out 5G, we have much higher downlink speeds towards the users. We have a very congested transport network. You want to know where in the network that you have those troubles, so that you can focus your investments where they matter the most. And to have the complete view also, not only focusing on your internal network. When we are talking about the user experience, you cannot think that you are only responsible for monitoring your own network. You need to monitor it all the way to the service providers of those most critical applications, the YouTube videos, the streaming services, voice, video, etc., web. So you also need to monitor towards the internet. All right, that's all we had time for today. So to conclude, user experience monitoring is really key in order to get new customers and keep your existing ones. There's strong research suggesting this. In today's modern data networks, video is really the major reason why the performance of these networks are challenged, affecting those consumers and customers that are the high RPU customers, and actually 2/3 of your customer base. And depending on what sort of network application we are talking about, web browsing, voice, video, etc., they all have different requirements. You need to take that into account when you are setting up your monitoring strategy. And when you are doing that, if you're really interested in the network or user experience, I definitely also recommend that you augment the basic KPIs that you are collecting with these mean opinion scores as well, so you get a simple view overall the network, how it's performing in terms of from a user experience perspective. And the last point, so you also need to monitor intermediate devices to have a segmented view, so you know where you have the bottlenecks in the network, and you can target the investments in the right places. So for those of you who are not familiar, the PulseShore solution from Creanord contains all of these user experience monitoring capabilities, in addition to then also service activation testing and active monitoring, combined with also the service level agreement monitoring. It produces the basic measurements, and then it has all the analytics, reporting capabilities, and export of the data also to external systems for further analysis. And the nice thing with the solution is we have proved that we are interoperable with all major network element vendors. So in terms of the segmented view that we talked about, you can still deploy a probe centrally, and then you can monitor towards your Cisco devices, towards your Juniper devices, towards your Huawei base stations, Ericsson, Nokia, ZTE, and so forth. We have validated interoperability with all of these major vendors. So you can use your existing devices in the network as reflectors. And there's no need for investments in those parts of the network. You just deploy a central probe and our Pulse Score server, and that's it. A very simple way to build up the monitoring solution. And that provides the full view of the performance across your entire data transport infrastructure. All right, that's it for today. I hope this was insightful for you. If this raised some questions, I'm happy to answer. Actually, I have a question from the audience here. Can the system work on top of existing monitoring systems? And answer is yes. This is a very nice solution. We actually have some blogs also outlining why our solution fits very well into existing OSS environments, because when you deploy our solution, like said, we are interoperating with all of the devices, so we can measure across all of that multi-vendor environment that you have. So we provide a full view into the data transport, but we don't assume that you are using our tools to report the data. We can export this data into any of your OSS systems. And the benefit of the fact that we are centrally collecting this data means that your reports and the data that you are getting is consistent across all of the different vendors that you have in your network. Another approach how to build an end-to-end performance view over your whole data transport network is, of course, that you have multiple EMS systems from each of these vendors that collect the data only from Cisco or from Juniper or from Ericsson, and then you export it from all of these EMS systems to an umbrella performance management solution, which then tries to mix and match the data. But the fact is that from the data from these different vendors is always going to be a bit different. Although there are very nice standards on everything, the data being exported is still going to be a bit different. There's going to be different KPIs reported. They're going to be calculated a bit in different ways, etc. With our solution, it's you still have just one solution that consistently calculates it, but we are still covering all of these multi-vendors. The only thing that Cisco or Juniper does is to reflect the packets back to us, and that enables us to provide very consistent reports and views into the performance. I have another question here. Can the system work with third-party probes and sensors already in use by the operator? Yes and no. So we do assume that you are using our probes in the central location. However, what we have done in certain customer cases, some of our competitors also have demarcator devices, for instance, that you may have located at the customer premise, typically for business services, and then we can measure towards those demarcation devices because they typically also have these TVAMP or UDP echo reflectors that we can utilize. So the demarcation devices we can reuse, but the third-party probes we cannot. But having said that, you only need to deploy a few probes centrally to cover the whole network. These are very scalable probes, scaling up to 15,000 sessions currently, and in a few months we'll release a new scalable option where we further increase the scalable manifold for the probes. So we have examples from Asia with a big mobile operator cover the whole mobile backhaul infrastructure, including also these routing devices with only 4 probes installed. So we are not talking about a massive operation. It's very cost efficient to deploy. So very nice. If you have some other questions, please feel free to send it out. You can see my email at the bottom of the slide. Check out the other webinars. If you got interested, I'd be happy to set up a session to talk more and provide you more information about this solution or about active monitoring, service activation testing, service level agreement monitoring, etc. And I hope you found this insightful, and I hope to see you in our next webinar.